This is Algebra 2, Unit 4, Lesson 2 on rational exponents. Now, all of the exponents that we've been dealing with lately are either positive integers or negative integers. They're all whole numbers. We are going to extend the rules for exponents into what's called rational or fractional exponents. So yes, exponents can be fractions. So we are going to look at where they come from and how to work with them. So first of all, let's recall the product property of exponents and use it to rewrite each of the following as a simplified exponential expression. So we don't have to find the final value. We just want to be able to rewrite this with a base and an exponent. All right, 2 to the third to the fourth power. Well, remember the product property rule of exponents says if you have x to the a and raise it to the b power to a power, you multiply the exponent. So this would be x to the a times b. So 2 to the third raised to the fourth power is really 2 to 3 times 4, which is 2 to the 12th. All right, so applying that logic to both positive and negative exponents, 5 to the negative 2 to the 5th would be 5 to the negative 10th. 3 to the 7th to the 0 power is 3 to the 7 times 0, which is 0. And actually, this is going to equal 1 because anything to the 0 power always equals 1. All right. How about 4 squared to the negative 2 squared? Okay. When you're working with exponents, multiple exponents, you work from the inside out. So we want to do 4 squared to the negative 2 first, which gives me 4 to the negative 4. And then I want to square that. So this is going to be negative 4 times 2 will be to the negative 8. Okay, so now that we've worked with the product property, we're going to use it to extend the understanding of exponents to include unit fraction exponents. So those in the form 1 over n, where n is a positive integer. Now let's use the product property to see if we can figure out what 16 to the 1/2 really means. Okay, if we apply the product property to simplify 16 to the 1/2 squared. All right, so power to a power means we take 1/2 and multiply it by 2. So that's going to equal 16. Now, what we are saying is when you take something and square it, you end up with being 16. But this is 16 to the 1/2. All right, what squared actually equals 16? It is equal to 4. So if 16 to the 1/2 is equivalent to saying 4, what does that tell me about what the 1/2 means? Well, how does the 16 relate to the 4? 16 to the 1/2 power would actually be the square root of 16 is equal to 4. So 16 to the 1/2 is equivalent to saying the square root of 16. So an exponent of 1/2 is equivalent to the square root of a number. Okay, now that's actually, we'll be talking more about this later on, but the 1/2 power, when you see the 1/2 power, the bottom number is whatever root you're in. We don't usually write a little 2 right here for the index. If there's no number there, it's assumed to be a square root. So that is the root number that we are in. So this is 16 to the 1/2 power means the square root of 16. The 1 is actually the power. So when you see 16 to the 1/2 power, it is 16 to the first power with the square root. So the square root of 16 to the 1 power, or 16 to the 1 power to the square root. So this is the power, and this is the root. With a square root, we don't usually write the 2 there. It's usually assumed. So we know that. All right, so let's take a look at that. Now that we know that the 1/2 power exponent is equivalent to the square root, let's look at the equivalents. 25 to the 1/2 power. All right, according to what we were just saying, that should be the square root of 25. Well, what's the square root of 25? It is 5. Now, if you're not sure, you can put this in your calculator. 25 to the 1/2. 25 raised to the 1/2. 1 divided by 2, or you can use the fraction key, but that's fine. All right, now to get it off the exponent, you have to forward arrow. And then press enter, and it's 5. 25 to the 1/2 is 5. If we try the next one, 81 to the 1/2. That actually means the square root of 81, which should be equal to 9. Let's see if that works. 81 raised to the 1/2 power. Yep, it equals 9. So we're correct. All right, 100 to the 1/2 power. All right, that actually means the square root of 100, so it should equal 10. Let's see if it does. 100 raised to the 1/2 power, and forward arrow off of there, enter. It's 10. There we go. So the square root is actually the 1/2 power. We can also extend this to other powers as well. You can your first power on the top does not have to be 1. It can be other things besides 1, and you can have a bottom power of 2 that's something else. So let's take a look at a couple of those. Okay, so to extend that, we know if for unit fraction and exponents, b to the 1 over n is equal to the square root of, or the n root of b. So remember, the 1 is the power, so this is b to the first power, and the root is the index right here. This is the root or the index. So if this is 1/2, like we said, if the bottom number is 2, that's assumed to be a square root. If it's any other number, it would be a different root. Okay, so if we know that's power and that's root, 125 to the 1/3 power. It is saying what root of 125? Well, the root is right there. So this is going to be the cube root. Now we put the 3 on there as the index to show that's not a square root. When you have a number here, it's other than the square root. 125 goes here, and technically it's to the first power. So 125 to the 1 over 3, 125 to the 1/3 power is the cube root of 125. All right, now, do you know the cube root of 125? What times what times what gives you 125? Well, it would be 5. All right, in case you didn't know that, you can do that on your calculator. All right, the cube root button is under the math key. If you press the math key, look at number 4. Notice here it's a square root symbol, but it's got the little 3 in front of it. That is the cube root. Okay, so we would pick number 4. So the cube root of 125 is 5. All right, 16 to the 1/4 power is actually equivalent to what root of 16? All right, it would be the 4th root of 16, technically to the 1 power. Okay, so the 4th root of 16. What times what times what times what gives you 16? Well, it would be 2. Now, let's see. The 4th root, if I press the math key again, now this time square roots have their own button, cube roots have their own button, any other root has this button for number 5. Notice right here is the root symbol with the X in front of it. If you pick that one, you have to indicate what root you're doing. So the little exponent kind of looking thing up here, that is the index, will be 4. And the 4th root of 16 is equal to 2. Now you can also do it with the exponent as well. 16 raised to the 1/4, you can check it, is also equal to 2. So they're equivalent. This is going to equal 2 either way that you do it. So power over root. Okay, here's a little application problem. 9 to the negative 1/2. Now, do we usually deal with negative exponents? No, we usually make them positive by the rule for negative exponents. Now, if we have x to the negative a, how do we make an exponent positive? Well, you use its reciprocal. So this would be 1 over x to the a. All right, so 9 to the negative 1/2, if I wanted to rewrite that with a positive exponent, I would use its reciprocal. It would be 1 over 9 to the 1/2. Now, what did we say 9 to the 1/2 is equivalent to? It's the square root of 9. So it's 1 over the square root of 9, which would be 1 over 3. All right, and then you can do 9 to the negative 1/2 in your calculator. 9 raised to the negative 1/2 is 0.333, but if we hit math, enter, enter, it is 1/3. Okay, so 32 to the negative 1/5. If I rewrite that with a positive exponent, it would be 1 over 32 to the 1/5. All right, and then I want to deal with my exponent. 32 to the 1/5 means what root? It would be the 5th root of 32. Okay, so the 5th root of 32, again, hit your math key. You want to do the x root here, number 5, and then you have to enter your index of 5, and then 32 here. and that's also equal to 2. So this is going to be 1 over 2. So it's a half. And again, if you want to check it, 32 to the negative 1/5, make sure you're right. Negative 1 divided by 5, forward arrow to get out the exponent, and is 0.5, which is a half. Okay. All right, now let's see if we can extend our rule for rational exponents to other exponents besides just 1/2, 1/3, or 1/5, or whatever I happen to be working with. Let's look at the expression 4 to the 3/2 and see if we can extend the understanding about it. All right, fill in the missing blank, then evaluate this expression. 4 to the 3/2. If I wanted to write this an expression as raised to the 1/2 power, okay, power to a power I want to multiply. So if I did something multiplied to 1/2, exponent multiplied to the 1/2, 4 to some power multiplied by 1/2, how am I going to get 4 to the 3/2? Well, what would have to go here multiplied by a half to give me 3/2? Well, if the exponent's going to stay, the denominator is going to stay the same, so this would have to be 1. 1 times 2 is 2. And the top would have to be 3. So this would have to be 4 to the 3rd to the 1/2. All right, so let's evaluate this expression. 4 to the 3rd is 64, because it's 4 times 4 times 4. 64 to the 1/2 actually means the square root of 64, which is equal to 8. Okay. Now, what if I went a different way? What if I wanted to take something and cube it and end up with 3/2? Okay, so I want to raise 4 to some power cubed, and I want to end up being 4 to the 3/2. Okay, so what number would have to go here? Remember, this is over 1. Okay, well, the denominator would have to be 2. The numerator would have to be 1. 1 times 3 is 3. 2 times 1 is 2. So this would have to be 4 to the 1/2. All right, now let's evaluate this. 4 to the 1/2. Well, 4 to the 1/2 is equivalent to the square root of 4, which is 2. And then 2 cubed is 8. Look at that. So we have just found if we did the 3 first and then the 1/2, or if we did the 1/2 first and then the 3, they are equivalent. All right, so what is this telling me? That is telling me that if I do the 4th root of 3, or excuse me, the 4 raised to the 3/2 power, I could write it like this. I could write it as the square root of 4 cubed and get 8, or I could do 4 cubed, take the square root, and I still get 8. So I could do the exponent first and then the square root, or I could do the square root first and then the exponent, and I'll still get the same answer. All right, so it doesn't matter which one you do first, the power or the root. Okay, so 27 to the 2/3 power. All right, so what is this equivalent to? 3 is the root, 2 is the power. So we could write this as the cube root of 27 squared. Now, I can either square it first or square it afterwards. So I'm going to square it afterwards. The cube root of 27 squared. All right, the cube root of 27 is 3, because 3 times 3 times 3 is 27, and squared is equal to 9. Okay, now could I also do this? The cube root of 27 squared. Well, let's see. 27 squared is equal to 729. And the cube root of 729, if I hit my math key, number 4, and grab that, I also get 9. So it doesn't matter. You can do the root first and then the exponent, or the exponent first and then the root. It doesn't really matter. But what you do have to know is the fractional exponent means power over root. So for the rational number m over n, b to the m over n can be the n root of b to the m power. You can do the exponent first and then the root, or you can do the root first and then the exponent. It doesn't matter. All right, so let's leave exercise 6. See if you can work these 3 out, and we'll go over them in class before we do the homework, and so that we can sum everything.